Welcome to an introduction to chemistry, brought to you by Parkbench Tutors. For more information about Parkbench Tutors, look us up on Facebook or visit parkbenchtutors.com. This is the third of our support tutorials on phase changes in chemistry. Let's consider a worked example building on our second tutorial. A solution of hydrogen chloride gas dissolved in water has a concentration of 30% of HCl by mass. So how much solute is there in 100 milliliters of the solution if we have the specific gravity of the solution as 1.15 grams per milliliter? Okay, where do we start here? Well, we need to start with finding the mass of the solution. If we know that the volume of it is 100 milliliters and the specific gravity, or if you're older as me, the relative density is 1.15, multiply 100 by 1.15, we have 115 grams. So now we have the mass of the solution. Mass, remember, is density times volume. So the mass of hydrogen chloride will be 30% of this, because we said it had a concentration of 30% of HCl by mass. So 30% of 115 grams is 34.5 grams. That's 30 divided by 100, then multiplied by 115. Okay, let's just recap on a few useful terms here as well. Gram formula mass is the formula mass expressed in grams, whereas gram molecular mass is a term we use when the substance is molecular rather than ionic. Molarity, which is the more common term, molarity is the number of moles of a substance dissolved in 1 litre of solution. So it's the volume of solution that's relevant in molarity. So if I take a 1 molar solution of H2SO4, there are two hydrogen atoms, one sulfur atom, 4 oxygen atoms. So I take the atomic masses, 2 times 1, 1 times 32, 4 times 16, giving me 2 plus 32 plus 64, giving 98, so that's 98 grams. So 1 molar solution of H2SO4 would have 98 grams in 1 litre. Right? Remember, molarity is the number of moles of solute in 1 litre of solution. Here's another little worked example for us. How many grams of sodium hydroxide are dissolved in 200 milliliters of solution if the concentration is 1.5 molar? Well, the molarity is the number of moles of solute over per litre of solution. So the molarity is 1.5 over 1. Right. So for 200 mils, if the molarity is 1.5, then the molarity we're looking at is 1.5 over 1 multiplied by 0.2, which will give us 0.30. So the molar mass of NaOH is 23 plus 16 plus 1 is 40 grams. So 0.30 times 40 is 12 grams of sodium hydroxide. Right, so we found that we knew how much, so it would be 40 grams of sodium hydroxide in a molar solution. Actually it would be 60 in a 1.5 molar. So all I had to work out was basically what was a fifth of that, and that's a fifth of 60 is 12. So that's just a sort of shorter in the head way of checking. Right, so molality then is slightly different. Remember, the first one I referred to was molarity, but molality is the moles of solute in 1,000 grams of solvent. So it's the amount in a certain mass, and it's usually referred to with a small m. So it can be a bit confusing. But molality then is the moles of solute per 1,000 grams, whereas molarity is in the number of moles in 1 litre of solution. So here's a little worked example here. 0.25 moles of sugar are dissolved in 500 grams of water. What is the molality? Right, remember we're dealing now with masses. So that's moles of solute per 1,000 grams of solvent. So 0.25 moles in 500 grams is 0.50 moles in 1,000 grams. So the molality is 0.50. Yet another term is normality. Normality is the number of gram equivalent masses in 1 litre of solution. So the question is, what's a gram equivalent mass? It's the amount of substance that will react with or displace 1 gram of hydrogen or 8 grams of oxygen, right? A gram equivalent mass is the amount of substance that will react with or displace 1 gram of hydrogen or 8 grams of oxygen. So let's take H2SO4, which has a gram formula mass of 98 grams, and there are 2 hydrogen atoms here, so the gram equivalent mass is 98 divided by 2, which will become 49 grams. What about aluminium sulfate? Well, the gram formula mass is 150 grams, and there are 2 aluminiums, each of which has +3 oxidations, so we can say it's a +6. So I'm going to take the 150 grams of the gram formula mass divided by 6, so I get a gram equivalent mass of 25 grams. And here's another little worked example for you. 49 grams of sulfuric acid is mixed with water to make 500 mils of solution. So what's the normality of it? First I need to find the amount in 1 litre of solution. So 1 divided by 0.5 multiplied by 49 gives 98 grams. There would be 98 grams in a litre. So how many gram equivalents have I got? Well, it's 98 divided by 49, which comes to 2. So my solution is twice normal. Dilution. What do we mean by dilution? Well, if a solution is diluted, the number of moles of solute in it remains the same, right? It's just the volume it's dissolved in that changes, so the concentration will change. So the number of moles times the volume will be the same even after we've diluted it. So M1V1 is equal to M2V2, right? The moles times the volume. Let's have an example of that. So we want to make 1 litre of solution that is 3M, and it is started. Sorry, we want to make a litre of solution that's 6M, and we start off with a 3M solution. So how much water do we need to do? Well, if M1V1 is equal to M2V2, 6 times 1 must be equal to 3 times the number of litres. So 6 times 1 must be equal to 3 times 2, so the answer is 2 litres. So to dilute the solution we add 2 minus 1, that's 1 litre of water. That's the end of this little session, brought to you by Parkbench Tutors, narrated by David Hopcroft. Thank you for watching and for listening. We wish you success in your studies. For more information, find us on Facebook or look up parkbenchtutors.com.